everyone, and welcome again to Pharmaceutical Calculations with Dr. Dave. In this video, we're going to be looking over density and specific gravity. Now, for pharmacy, a lot of times we're using density or specific gravity to convert a liquid to a measurement amount or a measurement amount to a liquid. So we need to measure something in mLs, and we want to use a balance to measure that. We can do that, or if we want to measure something in grams and we don't know how many mLs that is, we can do that. So this is where the density and specific gravity usually come into play. As we discussed earlier, there's an important number that we need to know, and that is for water, that 1 cc of water, right, 1 cubic centimeter of water, or 1 ml of water, has a mass of 1 gram at our temperature. So this can therefore be expressed as a density of 1 gram per ml. So water has a 1 gram per ml density, meaning 1 gram of water will fill up a volume of 1 ml. So density is going to be a definition of mass per unit volume. So how much mass, which is 1 gram in our case for water, and the volume that it takes up is 1 ml. So density is mass per unit volume. So if you have a question that if 10 mLs of mineral oil weighs 8.7 grams at 27 degrees Celsius, what is its density? So even though sometimes it's not explicitly stated, volume can change with temperature. So that's usually why something is measured at around 20 to 25 degrees Celsius or room temperature ranges. So anything that is given, in a sense, it should be given with a temperature, but that's not always the case. So in our case, we have 10 mLs of water. It weighs 87 grams. What is its density? Well, we know that density, right, is equal to, the density is equal to mass over volume. So for our case, we have the weight is 8.75 grams, and its volume is 10 mLs. Right? If I take 8.75 and I divide that on my 10 mLs, I'm going to get that 0.75. 0.875, this is grams per ml. You can have different units that you have for your density, but usually grams per ml is what we'll be using. So you can approximate that as the 0.88, let's say, grams per ml is what density of that mineral oil would be. Now, the follow-up question is, well, what would happen if you put mineral oil in water? If you know the density of mineral oil is 0.8 grams per ml, and you know the density of water is 1 gram per ml, which liquid will move to the top and which liquid will move to the bottom? Right? Because 0.88 grams is less, that's going to be less dense, it will move up, and the water will move down. All right, so specific gravity. Specific gravity, for our intensive purposes, you can interchange specific gravity for density in the way in which we use them for calculation. So don't get caught up on the specific definitions for density or specific gravity. It is the way in which the number was determined. So density is determined using specific instruments. Specific gravity is measuring the density of a material in respect to the density of water measured the exact same way. So again, the specific gravity of water is defined as being 1. There's no units on specific gravity. It's the only thing that changes from density. It doesn't have any units because it is a ratio, and the ratio has the same units in the numerator and the denominator, which is why they cancel out. But there are units there when we do calculations, but in a sense, when it's given to you, there are no units associated with the specific gravity. So how do you calculate specific gravity? You take a ratio. Like I said, it's the weight of a given substance to the weight of an equal volume of water at the same temperature. So that's what you do for getting the determination of specific gravity. So it is dimensionless. You're taking the weight of a substance divided by the weight of water, basically, an equal volume of water for that. So In our question, if we've got 25 mLs of a solution and it weighs 30 grams, what is its specific gravity? So we know that we need to take, for specific gravity, the weight of the material, so the weight, right? And the weight of water, I call it weight of H2O, of an equal volume, right? So the weight of 25 mLs of the solution weighs 30 grams. So if I measured the solution, 25 mLs weighs 30 grams. How much does water weigh if I have 25 mLs of it? If I've got 25 mLs of water, it weighs 25 grams. So this is what they mean when they say an equal weight, or the weight of equal volume of water, meaning you take the volume that you have and you say, what does water weigh if I have the exact same amount? So if you've got 25 mLs of the solution, how much does water weigh if it's 25 mLs? It's 25 grams. So you'll notice how the units cancel out. So when you have this unit, if you've got 30 divided by the 25, you're going to get 1.2. So 1.2 is the specific gravity of the material. No units, just a number. Some people will put designation here, SPGR, for specific gravity. You might see a dot next to those as well. So again, we use these for converting, and usually it's converting between weight and volume, or volume and weight. And for our purposes, when you see a specific gravity, you can assume that the units on it are just like the units that you see for density, right? So don't get confused that it doesn't have any units on it. We're going to assume what the units are. So the first question says, what is the weight in grams of 240 mLs of a syrup with a specific gravity of 1.33? How do you approach these problems? You always look at the specific gravity, and in your mind, you're going to convert this to density, and you're going to say 1.33 grams per ml. That's what you're going to use, right? So you've got specific gravity, which we're going to look at as equaling density. So we put the units of 1.33 grams per ml. And it says, how much does 240 mLs of a syrup weigh if that's the specific gravity, right? Well, we know that 1.33 grams is the weight of 1 ml. Right? If you know 1.33 grams weighs 1 ml, how many grams if you've got 240 mLs? And that's our math. We're taking 1.33 and we're multiplying it by 240. And in our case, we got 319.2. That would be the weight, right, in grams that 240 mLs of that syrup would weigh. Take another one. If 3 grams of propylene glycol, this is a liquid, are required to compound a prescription. We use propylene glycol a lot in something called levigation that we'll learn about in compounding. If we use that material and to compound a prescription, how many mLs of the propylene glycol should be measured out? So if you've got a compounded prescription, that compounded prescription says to mix 3 grams of propylene glycol with a powder. You're not going to get a graduated cylinder and put it onto a balance and weigh it. You're going to typically use a syringe or a small graduated cylinder to get the liquid measurement. So how much does 3 grams weigh? Well, we're given the specific gravity of propylene glycol, 1.027. So again, anytime we see this, in our minds, we're going to put that as density units. So we're going to convert that to density units, 1.072 grams per ml. Given that information, now we can utilize what the problem gives us. So it says we want to know how many mLs to weigh out. Well, I know that 1 ml, I'm going to measure out every time I want 1.027 grams of propylene glycol, right? How many mLs am I going to measure out if I want just 3 grams of the propylene glycol? We'll call it PG. Okay. And in this case, I've got my 3 divided by 1.027. And I've got 2.9211, so it's approximately 2.92 mLs is what I would weigh out for propylene glycol. Now, the way in which I'm doing these calculations, remember, if you want to do them as ratios, they're proportions, you can say 1 ml is equal to 1.027 grams. How many mLs is equal to 3 grams, people are used to. Remember, what am I doing? You're multiplying this side of the equation by 3 grams to cancel it out, and you're multiplying this side of the equation by 3 grams, right? This is the exact same thing I just did up there, right? To get my mLs, just saving the step. Don't get confused. So for these types of problems, I'm putting the unit that I'm looking for my answer on top, and I'm canceling out the denominator unit by multiplying by it. All right, so that's going from volume to, so you notice that when you do weight and you're dividing it by volume, you are dividing by the specific gravity. So going from weight, right, to mLs, I'm dividing by specific gravity. When I'm going from weight, right, sorry, when I'm going from mLs to weight, right, I'm multiplying by the specific gravity. So you can do it that way, but I would prefer you to understand what the units are and how you're getting the answer than just memorizing that. So notice, take your specific gravity, get it in units of density, and then do your proportions out. All right. So once again, that's density, specific gravity, and the conversions that we use them for. And as always, pharmacy calculations, the most important class that you'll have because it's the only one that counts.